Hi, we are students from Diploma in Science, and this is a video for CHM256 group project. In this video, we will talk about the evaluation of acidity in fruit juice, and we use pineapple juice for this evaluation. This is our team members, which is me, Siti Zulaika, Aina Akira, Ashwani Shrina, and Norhas Linda. This video contains introductions, theory, methodology, example of results, conclusion, and reference.
First of all, let me introduce first about pineapple. Pineapple is a tropical fruit known for its distinctly sweet flavor and rich nutrient profile. It is also an excellent source of vitamins, minerals, and antioxidants. Citric acid is the major acid in a pineapple and usually is determined by titration to a specific pH endpoint, while sugars are determined as a total soluble solids by refractometry. What is volumetric analysis? Volumetric analysis is a chemical analytical procedure based on measurement of volumes of a reaction in solutions. It uses titration to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another.
First, we talk about titration. Titration is a process in which a standard reagent of known concentration from a burette, which is tetran, is added to a solution containing the analyte until the reaction between the analyte and the reagent is judged to be complete. A general chemical reaction for tetrametric analysis is A plus T and will produce a product, where A moles of analyte A obtained in sample reacts with T moles of tetran T in tetran solution. Types of titration. There are many types of titration when considering goals and procedures. Firstly, acid-based titrations. The strength of an acid can be determined using a standard solution of base. Secondly, redox titrations. The chemical reaction takes place with a transfer of electrons in the reacting ions of aqueous solutions by oxidation-reduction reaction. Thirdly, precipitation titrations. The titration is based on the insoluble precipitate formation when the two reacting substances are brought into contact. Lastly, complementometric titrations. An undissociated complex is formed at an equivalent point. Application of titration. Here are some of the most common real-life application of titrations. Firstly, we can determine of solution concentration. Secondly, we can do a purification of chemicals. Third, we can do a quality control in industry. We also can do a study of reaction kinetics and do analysis of food products. And lastly, we can detect a drug dosage adjustment by drug titrations. Titration of fruit juice. Some citrus fruits taste more sour and therefore they are more acidic than others. The purpose of this experiment to determine the total acidity of pineapple juice. The citric acid content of pineapple juice can be determined through the titration of the juice. This process will involve a certain volume of juice having a base of known concentration added to it until a point is reached where all of the acid in the juice is neutralized, and it is known as the endpoint. Citric acid is a weak acid and is the best saturated using a strong base such as sodium hydroxide with the combination of a weak acid and a strong base, producing the endpoint that corresponds. The range of phenolphthalein indicator by the pH range is between 8.3 until 10. Now, we can see here, this is a titration process. Tetran is a standard solution for a burette of known concentration, and the analyte will be placed in conical flask with concentration we need to determine. And lastly, the indicator was added into the conical flask to determine the endpoint.
Okay, next we move to the next one is the methodology. So for chemicals, we must have the pineapple juice, standardized sodium hydroxide solution, distilled water, and phenolphthalein indicator. For apparatus, we must have 10 ml graduated cylinder, 250 beaker, 250 ml conical flask, burette, pipette, and pipette pump, and also restore stand and clamp, and also wipe tile. So next, we move to the next one is how a simple procedure how to titrate using pineapple juice. So for the first one, we must use a 10 ml of graduated cylinder and measure out 5 ml of fruit juice, which is pineapple juice, into the flask. Second, dilute the pineapple juice to approximately 100 ml of distilled water. Third, while stirring, add 2 or 3 drops of phenolphthalein indicator. Fourth, fill the burette with a standardized NaOH solution, which is sodium hydroxide. Fifth, titrate the prepared juice solution to the phenolphthalein endpoint. And sixth, record the final burette reading to the nearest 0.01 ml. And repeat step 1 until 5 to get 2 or 4 readings. And lastly, we must obtain a sample of a different juice and perform at least 2 titration trials.
Pipette, deliver 5 milliliters juice sample into the flask. Then I'm going to add some water, again deionized, just to increase the volume of the sample here. It makes it easier to do this whole operation. A couple drops of this phenolphthalein indicator. It's going to turn pink. The pH gets 8.2, that's the endpoint. I know from prior measurements this juice is starting at a pH of about 2.9, quite on right. Okay, so we'll come up here to the burette, and we are starting at 10.5 milliliters. Make sure to write that down. That's the one thing I mess up most, forgetting to write that down. Okay, now I'm going to scoop this in, so see this color mesh reaction. So I'm going to open this valve and start delivering the sodium hydroxide down into the juice sample, and you can see there's a bit of a color change there. It's turning pink. Oh well, it comes through in the video, but this pH of the juice is constantly increasing as we're adding the sodium hydroxide. We're shooting for pH 8.2. That's when everything is going to turn pink and remain pink. Right now you can see if I turn off this, the pink goes away, that's base is consumed. So we're going to continue this, maybe go a little bit slower, until this all turns and remains pink. The pink persists longer and longer as we get closer. Okay, the color's persisting.
Example of result. We use pineapple juice titration 10 ml. Final burette reading for rough is 19.8. Initial burette reading is 0 and volume and AOH used is 19.8. For first trial, final burette reading is 19.8. Initial burette reading is 0 and volume and AOH used is 19.8. The second trial, final burette reading is 18.9, initial burette reading is 0 and volume and AOH used is 18.9. For third trial, final burette reading is 20.2, initial burette reading is 0 and volume and AOH used is 20.2. So, for average, we need to multiple value of volume and AOH used in trial 1, 2, and 3 and then divide it by 3. The average we get is 19.63. Next, calculation of acid content. Volume of acid is 0.01 liter. Volume of NaOH is 0.0163 liter. Number 2, we need to find moles of NaOH. Molarity times volume. 0.1 mole per liter times 0.01963 liter. And the answer is 0.00193 mole. So number 3, mole of acid, 0.00193 divided by 3, and the answer is 0.000654 mole. Number 4, mass of acid, number of moles times molar mass, 0.000654 moles times 192 gram per mole, and the answer is 0.1256 gram. And the acid content 0.1256 gram divided by 0.01 liter. And the final answer is 12.56 gram per liter. Next, this is the graph titration data for pineapple juice. that we get.
In conclusion, acidity of fruit juice can be determined by titration with basic solutions with known concentration or standards. Titration furnishes more detailed clues for certain perishable items, including fruit juice, that are sold as blends or may be subject to adulteration. This testing can be important of meeting local labeling requirements, in addition to preventing allergic reactions or other forms of illness.